All right, let's look at this area of irregular shapes first. So how is this different than what we've been doing with area? So we've been doing parallelograms, we've been finding the area of rectangles, we've been finding the area of triangles. How is this a little bit different or a little more complicated? Yes? They're different shapes all mushed together, right? So here, what two shapes do we have? Michael? We have a rectangle and a triangle. And we want to find the area of the whole thing. Okay, so this is a little bit more complicated. And based on what I saw from your triangle homework yesterday, we're still having a little bit of difficulty just with area of triangles. All right, so to find the area of a rectangular shape, here's the steps. Use dotted lines to break the irregular shapes into shapes with formulas. So we do know the formula for a rectangle and we do know the formula for a triangle. Find the area of each individual shape. So we'll find the area of this and then we'll find the area of this. And last, add the area measurements for each shape to find the total. That's all there is to it. So I'm going to use a couple of different highlighters to help me see. If you have highlighters you want to use, you can. All right, so let's take a look at number 1. The height of the triangle and the shape below is 4 centimeters. So they're going to tell us the height. Right there is 4 centimeters. So we do need that information. Oh, let's start with the rectangle. What are we going to multiply together to find the area of the rectangle? Because I see 3 different numbers that have to do with that rectangle. What is the base and the height of that rectangle? Yes. Yes, so 12 times 2 equals 24 centimeters squared. So that one was pretty easy. All right, we see the height of the triangle is 4, so the height is 4. But what's this base right here? How am I going to find that base? There's no number there. So here's where I've got to do a little bit of thinking. I've got to do a little bit of math. So what do we know about the base of the rectangle? What's the base of the rectangle? Somebody besides Grace. Maddox. 12. The base of the rectangle is 12. That means this side right here is also 12. Here is 9. So what number plus 9 equals 12? 3. So I know that this has to be a 3 because 3 plus 9 equals 12 centimeters. Does everyone know how we know that is a 3? Because 3 plus 9 is 12, and this is 12, so this is 12. Does that make sense? Okay, so the formula for area of a triangle is 1/2 base times height. 1/2 on our calculator is 5/10. The base is 3. The height is 4. So what is area of that triangle? What do we get? 3 times 4 is 12, but what's half of 12? 6. So it's 6 centimeters squared. So what's the area of the whole composite figure or irregular shape? We're going to say 24 centimeters squared plus 12 centimeters squared is 36. Oh, no, it's not 12. It's 6. What was I thinking? I was thinking wrong, wasn't I? So let's fix that. So this is 24, but this one is 6 centimeters squared. So what's our answer? 30 centimeters squared. 30 centimeters squared. All right, any questions about how we found the total area? All right, so look at the second one. Go look at the second one and see if you can figure out what shapes you're going to break it into. What shapes are we going to break that second one into? What do you think, Michael? 2 squares and 1 rectangle. Yes, I think you're going to have to break it into 3 pieces. So I think we're going to have to break it here. And I think we're going to have to break it here. So let's start with the squares up on the top. Base times height, what do we get? 2 times 2, and we get 4 feet squared. And over here, well, I see the 2 here. How do I know what the height of that one is? Yes. So I'm going to use this whole section right here because that whole thing is 4. But I'm just talking about this part. I'm going to look over here, right? What is it, Brianna? It's going to be 2. This height is going to be the same as this height. Or 4 minus 2 is 2. So it's going to be the same as this one. It's going to be 4 feet squared. Then I want you to look and think about the base and the height of this rectangle. What's the base? 12. What's the height? So this rectangle goes all the way up there. It's going to be 2. I've got to take that 2 off, right? Or I can look over here. 2 plus this 2, this part, plus this part has to equal 4. So if I have 4 here, and I take that 2 off, that makes this side 2 feet. So 12 times 2. So you have to be careful with what dimensions you're using. So 12 times 2 equals 24 feet squared. Now how do I find the area of that total composite figure or irregular shape? I'm going to say the total area is 24 feet squared plus 4 feet squared plus 4 feet squared. And what do we get? What do we get? 32 feet squared. So the total area of that composite figure is 2 feet squared. All right, look at number 3. There's 2 different ways to break number 3. Look and see if you can decide which 2 ways you can break number 3 apart. All right, what do you think, Michael? So a rectangle and a square. I don't know that that's ever going to be a square. I don't know that the dimensions are ever. It looks kind of square-ish. So there, I can break them here into two rectangles. Or I could break them here into two rectangles. Which way do you want to do it? This way? Okay. All right, so let's look at this first one because it's going to be easier. The base times the height. 7 times 8 is 56 inches squared. All right, so now I've got to think about here. I know this height is 2, but I got to figure out what the base is. How did you get 7? So I don't know that I can necessarily always divide it by 2. So I can think about this whole top is 14. This part right here is 7. 7 plus what number equals 14? To me, this looks like a garage door that moves up and down, right? So the garage door is all the way up. If I push it down, it's going to equal this top length, 14. Push it down, something plus 7 has to equal 14. And what is that something? 7. So sometimes you have to think about it, and you see that is 7 inches. And 2 times 7 is 14 inches squared. And then how do I find the area of the entire shape? Add 14 inches squared plus 56 inches squared is 70 inches squared. Total area, 70 inches squared. Not too difficult? No? Okay, let's put that to the side. We'll put it in our journal in just a minute. But I want to look at the other notes page. This is a little bit more complicated. A little bit more complicated. All right, so there are other ways to find the area of composite figures. What we were doing over here is called decomposing. That means breaking things apart, decomposing. And you find the area of each thing and then you put it back together. Here I could, instead of decomposing, I could put this corner back on. I could put that corner back on. Find the area of the entire rectangle, and then find the area of that triangle and take it back off. So I could use subtraction instead of addition. So I could add this corner back on, find the area of this whole shape, find the area of this triangle, and subtract it off. So we can do that in two different ways. Do you want to try it like that, or do you just want to decompose it? Okay, let's decompose it first. Let's break it apart, and then we'll check it the other way and see if it works the other way. All right, so what are the shapes we're going to break this in? You might have to do some trial and error. My 7th graders last year, when they were 6th graders, just wanted to break that into 2 pieces, but I'm not sure that 2 pieces works. Is something happening outside the door? Does someone need to come in? Are they still there? Well, then why does that matter? Will you go push the door all the way closed, please? Is it a, oh, it's not a, like a kid or something, it's a working person? No, it's a kid. Oh, well then why wouldn't you do it? Oh my word. We're very dramatic. Okay, all right. So, what do you think? What are we going to break it into? Did anybody try anything? What do you think, Aiden? I don't see 4 pieces, so I think you could break it this way and this way. So you have a rectangle, and a triangle. I see another way to break it. And any of these ways work. Break it all the way this way. And then break that apart. So I have a rectangle, and a triangle. Okay, do we want to leave it like that? Are we all okay with that? All right, so let's start with that big rectangle. Base times height. Do we all see the base and the height? What are we going to multiply together? Hello? What are we going to multiply together? Okay, so 5 3/10 times 8. And what does that equal? Okay, 42 4/10 inches squared. All right, now let's look down here at this little guy. So I see the height. The height's pretty easy. 4. I've got to do some thinking about right here. This whole thing is 8. This whole thing is 8. What is this part right here? What is this part right here? Let's look up here. So this length right here is 5.3. So plus whatever this is has to equal 8. So what is this length right here going to be? How am I going to do that math? A number plus another number equals 8. If I don't know what this is, I need to do what? What is it, Michaela? Yes, it's subtract. So what number did you get? Yes. 2.7, 2 7/10. Because if I add that to that, I'm going to get this whole length of 8. Everyone see how we figured that out? Okay, now we're going to multiply 4 times 2 7/10. And we're going to get 10 8/10 inches squared. Now I've got to think about this. The base and the height. Well, there's no numbers there, Mrs. Miller. I don't have any idea what we're going to do. There are no numbers that have to do with that triangle. Sheesh. Anybody got any ideas? We just make them up. What do you think, Ava? The same as this? Yes, this is 2 7/10, so this is 2 7/10. I see that. All right, so now I've got to think about this height. Yes? Okay, so actually it is about half of the 8. I can tell that because this is 8, and from here to here is 4. So this plus this has to equal 8. The math is there. 4 plus 4 equals 8. So the math is there. This height is 4. So remember, this is a triangle though, so it's different. What do we have to do? 5/10 times 2 7/10 times 4. Do that on your calculator. Anybody get it? Nope. 5 4/10. So it looks like this, guys. 1/2 is 5/10 times 2.7 times 4. 5 4/10. Again, half is 0.5 times 2.7 times 4. And you get 5 4/10. 5 4/10 inches squared. That's this shape right here. Now what's the math that we're going to do? We're going to add them up. That plus that plus that. So we're going to say 42 4 inches squared plus 10 8 inches squared plus 5 4/10 inches squared. Add those up. We should get our answer. And we get 58 6/10, 58 6/10 inches squared. All right, questions about that one? No? Okay. All right, do you want to see it when we decompose it, how we would do that math? So if I were to put this all back together, the base is 8 and the height is 8. So 8 times 8 is 64. Okay, now if I'm going to put this triangle back on, it's the same as that triangle, right? Because we learned in our experiment that's half. So let's subtract 5.4. Let's take this other half of the triangle off, minus 5.4. And what do we get? You get the same answer. 64 minus 5.4, and you get 58 6/10 inches squared. Is that the same thing that we got there? Yes. It's the same math. So that would be how you would recompose it. All right, you can do it any way you want. Most of my students, since they're just used to breaking it apart and adding it, that's what they do. Down here at the bottom, we're going to have to do it differently. All right, let's look at this next one. What shapes are we going to break it into? A what? A rectangle and a triangle. We're going to break it right there. I want you to think about what we're going to multiply together for the rectangle. What's going to be the base and the height of the rectangle? Talon. 15 times what? So this height right here is the whole rectangle. I'm not sure I agree with the 15. Anybody else have did you say the 15 or no? Oh, what did you say? The 10 and 7. I'm sorry. That is exactly right. The 10 times 7. I'm sorry, Talon. 10 times 7 equals 70 centimeters squared. All right. Now we've got to think about this triangle. I'm going to turn my paper to help me. So I'm looking for the base and the height. The base and the height. So the base is what it's sitting on. And the height goes from the base to the tippy top point. There's no numbers for either of those written on there. So we've got to do some comparing. Anybody have an idea of what the base would be? Do what? I want to know what this base is going to be. It's going to be 7. Does anybody know where she found that from? Talon? Yes, it's the same as here. This and this are the same. Right? Because this side on the rectangle is the same as that side. So the base is 7 centimeters. Okay? Now where am I going to get that height from? So if I'm looking, the height here is going to be this part over here. So I know that this is 10. So I know this is 10. And so this whole thing is 15. If this is 10 and this whole thing is 15, what has to be that height? Grace? 5. This height is 5 centimeters squared. So is the area of that rectangle 35? Is it 35 if I do the math? It's a triangle, so what do you have to do? Divide 35 by 2. Or you could say 1/2 of 7 times 5. So 1/2 base times height. So 5/10 times 7 times 5. Try that on your calculator. 5/10 times 7 times 5. And you get, yep, 17 and 5/10 centimeters squared. Then how are we going to find the area of the entire, I think that looks like a little house. Right? Grace, how are we going to find the area of the entire shape? Okay, so I think you've got one too many. There's just 2 shapes. We want the area of 2 shapes. So we're going to say 70 centimeters squared. And we're going to add to that what? Yes, 17.5 centimeters squared. And we are going to get 87 and 5/10 centimeters squared. All right, easy enough? Yes? Okay, we're going to do this one in, excuse me, in just a minute, but we need to cut this first so it fits on our page because we're going to need to write on our page a little bit. So we'll get it in our journal before we do that problem. All right, so 118 through 121 is going to be your area of irregular or composite figures. Table of content. Table of content. I'm not sure how to help you with that. If there was an emergency and we had to evacuate, you've got to have your shoes on. All right. Everybody good there? Okay, so the first sheet that we did, you're going to have to cut in half like this to get on page 118 and 119. So this page, we're going to cut in half and put it on page 118 and 119. All right, so 118 and 119, we're gluing those on. Turn the page, you've got 120 and 121. We're going to glue this on here, and then up at the top we're going to write area of composite figures. Composite figures just means more than one figure pushed together. And then we're going to look right down here. We're going to do this work right down here. All right. So, what's up with this shape? To me, it looks like a swimming pool. And it looks like the part with the steps is cut out. That part's missing. So, how is it different than the first two that we've done? It's not really necessarily different than the first one. There's part of the first one missing. So, this, we're going to find the area of the entire rectangle. Then we have to find the area of this missing part. And then what would we have to do? Would we add it together or would we subtract it off? Yeah, we're going to have to take that missing area and we're going to have to subtract it off. So let's think about the base and the height of the rectangle first. All right, so the base is 16 and the height is 12. And that will be the whole shape, including this missing shape. So we're going to say 16 times 12, and we're going to get 192 feet squared for the rectangle. Everybody see that? What shape is this that's missing? This is smaller than this. That's a trapezoid. Do you all see how that's a trapezoid? Okay. Formula for a trapezoid is base 1 plus base 2 times the height divided by 2. So we've got to figure out what the base is. So we know that this part down here, this smaller part, is a 2. That's telling me that part right there is a 2. So I know that's a 2. Let me zoom in a little bit. Now I've got to figure out what this wider part up here is. What's this wider part right here? Well, 16 has to equal 6 plus whatever this is plus another 6. So if I say 16 minus 6 minus 6, or 16 minus 12, 16 minus 12, that makes the other base a 4. This top base is a 4 feet. And then I've got to figure out what the height is. Well, if this is 12 and from here to here is 11, what's that height? 11 plus what this height is has to be 12. So what's the height of the trapezoid? 10? Did I hear 10? 2? 11 plus 2 is 13. So the height's not 2. What is the height? 1. So the height is a 1. So to complete that formula, you're going to say base 1, which is 2. 2 plus base 2 is a 4 times the height of 1 divided by 2. 2 plus 4 is 6. 6 times 1 divided by 2. And 6 times 1 is 6. So 6 divided by 2. And 6 divided by 2 is 3. 3 feet squared for the trapezoid. Do you have all this written? And then we said that we're taking that trapezoid off. So that means we need to do what? We need to subtract. So it's 192 feet squared minus 3 feet squared. You get 189 feet squared. That is the answer for the entire shape.